Any of us.
Can start, but I was waiting. I'll be presenting a final project that I have developed in the past 1 year or so, working with Delhi, our sponsor. So the the project focuses. So what I have worked on majorly focuses on how to measure and manage risk in a data marketplace. So starting with the summary, as I mentioned, so the core of this project is to build a quantitative framework to score risk within data bundles, which we are calling it as cubes, and then using more than we I have used more than 65,000 bundle combinations and try to uncover key insights. What is rising the risk score overall, and what is reducing? What kind of different cubes are helping the risk? Sorry, giving the risk high score. So moving forward, with the introduction, there are a lot of different so there are marketplaces, like being a financial engineering student, there are marketplaces for data. So this project mostly involved a lot of machine learning concepts as a financial engineer, how to group data, how to correlate data with each other, and how to build a mathematical model based on all of this, which are qualitative in nature. So that was the task majorly. So the objective was, again, as I mentioned, to quantify any kind of residual risk or any kind of personal information data, and then classify them into different kind of research to categorize them, and then accordingly relate them with any kind of legal consideration like GDPR, we all are aware of, or HIPAA for any kind of health protection acts. Then then moving forward, to build a scoring engine on the basis of those cubes, and depending upon the verifiability of the data records, and then recommend any kind of governmental regulations or technical safeguards to limit any kind of sorry, to give a score output. So the data for this, what I built personally, so everything was custom built by I and the team in the starting. We built it with help of Delhi. So there's no data taken from any other place. It's all self-built. So so the challenges in this project, starting with, I would say, it is it is tough to quantify any kind of qualitative data, and then to correlate it with any kind of other qualitative data sets. That was the major challenge, I would say. Then building a verification based trust, how can anything be verified, and how it will impact the overall scoring. Then I developed a dynamic weighting to avoid any kind of misalignment into the scores itself. And on the basis of all of this, I built a machine learning based classification model for all of the cubes. For the risk as well, so creating different risk, how one risk impacts the another, understanding them in a logical sense and also in a legal sense. That was the challenge in the beginning, which I faced a lot, not coming from a legal background. But yeah, that was really helpful and really helped me understand a lot of different things. And then to have different type of heterogeneous records combined with each other, how they react with each other, and what is the consistency. So one thing I personally which challenged me a lot was having a normalization of scores, so that I have been able to figure out, which I'll explain. So, so the methodology used were, we identified 23 different risk types, and each and every data type was accordingly evaluated on the basis of each and every risk type. Then we uh, any kind of data again was verified on was penalized on the basis of verifiability. And then then I created a weighing system to adjust any kind of difference in the risk type. Then in the finally, the total scores are basic mathematics, which is total score upon the maximum possible score for that particular cube, whichever the buyer is selecting. So the code architecture remains again. It is, as I mentioned, it remains simple to understand, which is calculate risk score, then calculate combined risk score of any kind of different cubes if you select, and then to dynamically classify on the basis of clustering. So the scoring model, I'll try to explain how the verifiability works. So let's say any kind of data. So let's say a name. If I take name and in a so, okay, let's go with social security number for any kind of financial data record. So social security number will have a high risk, which in my model it will always score it as a 3, 1, 2, and 3, low, medium to high. And then so the formula for this is simple. So if the data is verified from any government source, it will give it a bonus point of any plus point 2 to plus 0.5, depending on the range of either it is low or medium. Whatever will be the minimum will be selected from both of them. And then if it is not verifiable, it is penalized on the basis of uh, -1 to -2, again depending on the high risk attributes. Then I'll try to explain the k-means clustering that I've used, which I mentioned. The major challenge which I faced was the normalization of scores. So how this has been inculcated is in the end, when all of the percentages are calculated for let's say for m cubes, as it can be seen in the slide. So based on that, it will normalize the score. It will calculate the normalized score for each and every percent, and on the basis of that, uh, so we will get a centroid value, and from the centroid value, depending, three categories will be divided: low, medium, and high. So it won't be like we did earlier Delhi, like less than, let's say, 35% or 40%. It will be low risk, more than 55% high risk. So depending on the different cubes we have, it will be automatically decided by the code itself, that depending on the center score which we are getting, which one is low, medium, and high. So that I was able to tackle it here with the help of k-means clustering. So the results, as I guess many of us have already seen this in our day-to-day Friday meetings. So the results usually show the total weighted score, the maximum possible score, the percentage score, and whatever the missing values are, and how the z-score is defining, which I mentioned, which is k-means clustering again. So this is the heat map. So I understand because there are more than 65,000 possible combinations, it's a bit trapped inside there. But here in the second graph, you can see that there are multiple. Yeah. So there are multiple. You can see the even distribution of low, medium, and high risk. And there are a few possible cubes into zero. That is the reason. So the reason for that is actually because the data records in those cubes are not available in our dictionary defined earlier. So that is something which can be done later. That is the only reason why they are zero. But if the data records are included, it will nullify that as well. Then coming to the top risk drivers. So I identify what are the top risk drivers, and as we can understand, mostly it is SSN, any kind of bank account numbers and passwords. So any kind of financial data or highly personal identifiable data will always give you a top risk, sorry, a high risk, which so it can be validated that the model is working and it is giving us better results. Sorry. And as I mentioned, any kind of financial data. So here we can see investment and retirement cube. So both of these cubes have all the financial data inside it. So that is why both of them have a high risk score in this case as well. Moving further, so the conclusion, high risk cube, as I mentioned, investment cube and retirement plan cube and debt management cube as well here. So the risk amplification, as I mentioned, so combining one thing I realized because I ran all through all the 65,000 possible combinations. And so when you keep on increasing the number of cubes that a buyer is selecting, the aggregate risk keeps on building up. So again, which validates that our model is working because it was built from scratch. That is why I keep validating it again and again. That as the number of cubes increase, the aggregate risk also increase. So the verifiability gaps. So there is a gap in this as per the verifiability algorithm which I have defined because the data records are not matching or still because there is no anything. So I've added only PI, any kind of PII data can be verified in this case, but not for any other kind of information or any kind of data record, which can be anything related to financial or something different. So that is why we can see a huge gap here, as it is mentioned. So there are data records types such as fantasies or to-do list. It can't be verified. So that is why the gap remains there. The critical risk drivers, as I mentioned, any kind of data sensitivity related to PII information or anything related to regulatory exposure, it will give us a high risk. And this also, I mentioned that combining more than three cubes, it highly reflects more risk. So on the basis of centroid that I mentioned earlier, so the low risk, as per the current setup, it is giving less than 22%, and any kind of high risk for more than 70% on key dimensions. The risk scenario mapping. So here I'll just fast forward it because others also have to need time. So if a buyer resells the data moving forward, that remains high that will impact our risk scoring. Combined cube of health and financial data is giving again a huge exposure to the risk. Any kind of unverifiable data traded is a risk for ourselves as well. Then the future work, there are multiple things which need to be done, but the major that I need to just point out is integration with any external data privacy framework like GDPR scoring, which will be helpful. And also k-means in current scenario, it assumes convex geometry, but a silhouette analysis may differentiate the low and high modes. So I feel that this will impact and monetary impact dimension, which I mean, what I mean by that is integration with Tolu's work. So yeah,
Mhm.
that's my side.